This is Algebra 3. This is our Unit 2 review, Part 2. We will complete the review today. Here's where we left off. With number 2, we made a frequency distribution, which is basically a table with class limits, tally, frequency, and relative frequency. And in number 3, we're going to use that table, that frequency distribution above, and make a histogram. So when I take a look at the frequency distribution, the table, the highest frequency is 3. And that means when I draw my axis, the highest I have to go on the vertical axis is 3. And we're going to label that frequency. Now I'm also going to use the class limits. And I can start at 0 here because the first number is 5. So why don't I'm going to draw a little squiggly line there. That means we're starting at 5. And we are going to go 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. Alright, it says 5 classes in the problem, and we have 1, 2, 3, 4, 5. We're going to have 5 different bars on the histogram, so that's 5 classes. The first set of class limits has a frequency of 3, and it goes 5 to 10. So I'm going to go up to 3 here. And I'll make a bar there. And then 1 for the next class. 1 for the next class. 3 again. And then the last one has a frequency of 2. There you have it. A nice histogram of our data set. We labeled the vertical axis frequency. We don't know what this data is, so on the horizontal axis we'll just put class limits. And we did label those class limits, 5, 10, 15, and so on. We have done everything that the question requires. Moving on. Here's part 2. In problems 4 to 9, determine whether the statement is true or false. Alright, I encourage you to pause the video and try these problems, and then I will go through them. Alright, here we go. Relative frequency can be written as a decimal. That is true. Normally we would write something like 3 over 10, but you can also write that as 0.3. The range is the lowest minus the highest. False. A data set can be skew left and uniform at the same time. False. The interquartile range, IQR, is given by Q3 minus Q1. True. 25% of all data values lie above the median of a data set. False. That should be 50%. 50% of the data values are above the median. Stem and leaf plots use the median to find the average. False. Number 10. Below are statistics for points per game by Michael Jordan from 1984 to 1998, one of my favorite basketball players. Excluding the 1993 to 1994 season where he tried to play baseball. It didn't work out so good. Create a stem and leaf plot of the data using the legend 2 with slash or vertical line 4. So 2 is the stem, 4 is the leaf. If I look at the data set, the highest value is 23 and the highest value is 37, the lowest value is 23. So my stem and leaf plot, I only need a 2 and a 3 for the stems. But the trick is I have to order this. So 23 is the smallest, 27, 28, 29, 30, 30, 30, 32, 33, 33 again, 34, 35, 37. Our stem and leaf plot is complete. Identify the 5-number summary. The reason why we put data into a stem and leaf plot is so we can easily see the minimum, the maximum, and then calculate the median, lowest, highest, so on. The median is 30. And now I'm going to ignore that median and look above that to find Q3. Here's 2 numbers in the middle, so Q3 will be 33 plus 34 over 2. Q1 will be 28 plus 29 over 2. And that is our 5-number summary. Finally, using your answer from Part 10b, create a box and whisker plot of the data. The highest value is 37. So I could start at 0 and probably go by 5s up to 40. 5, 10, 15, 20, 25, 30, 35, 40. With a box plot, we don't need to label anything on the vertical axis. The first whisker occurs at 23, and then the left side of the box occurs at 28.5. The median is at 30. The third quartile is the right side of the box, that's 33.5. And the last whisker occurs at 37. Finally, we'll label the bottom axis and we'll put number of points scored. And we'll say per game. My handwriting is not the best, but hopefully that makes sense. That is it. I encourage you to comment on this video in order to earn credit, and then have a nice day.